So today's webinar is about how to increase biomass boiler efficiency, and we would like to introduce Energy Advice company. I'm Vytautas Šiožinys, CEO of a company. I'm Doctor of Science. Topics of this would be about boiler operation with the help of digital twin IT system, benefits and limitations. Shortly introduce also what does it mean digital twin technology. Analytical system that automatically creates set points for efficient boiler control. Is it possible? Biomass boiler parameters and set points that should be optimized and could be optimized. Efficient biomass boiler control, possibility to reduce maintenance cost. Fifth topic, real-time biomass calorific value evaluation during biomass combustion. So can we evaluate fuel calorific value during the burning process? And human error that can be avoided using analytical system. We are presenting now EA-SAS Boiler. So process optimization and a value for biomass boiler. We should understand why we propose optimization and what does it mean optimization. In this chart is described benefit potential, what we can get from the automation. In this axis is provided capital cost, including manpower, and controllers which could be inside your process. It's the same controllers that could be in a biomass boiler, in technological process also. The meaning is general controllers. So the basic controllers solve near to 60–70% of manpower problems and creates near to 10% from the potential what we can get from the controllers. If we use enhanced regulatory control, we increase benefit potential and we save manpower's cost. We can use also a multi-variable control, automation system, SCADA system, process control system can use multi-variable and provide control. However, this reach only near to 70% of potential we can reach through regulation, and we need optimization of a process to reach 100% of a potential. Why this happen? Why we need optimization in biomass? Because in fact the fuel calorific value is unknown during the burning process, and because fuel calorific value is unknown during the burning process, we need to evaluate, and after this evaluation, the control system in fact is not capable to evaluate calorific value. But if we evaluate calorific value of the fuel which is burning during now in this moment, at this moment, 5 minutes range, 1 minute range, we can tell and we can optimize the operation. We can provide optimum supply of the fuel, optimum supply of the primary, secondary air, and etc. So this is a general value. How we do this? The question: do you need additional big investment to automation of your boiler? In fact, answer is no. You don't need to have very big investment, because we install Energy Advice data collector software directly to the SCADA computer, which data collector connects to the SCADA computer database. Or if you don't have database, your SCADA do not have, your control system do not have database, we connect directly to the controllers and read the data from the controllers. send this data to EA-SAS Boiler analytical system. It's accessible through cloud EA-SAS.energyadvice.lt. You can just type and you find login screen. And all data collected in second range, transmitted to the analytical system. Inside the analytical system, mathematical model, digital twin model is run, and each 5 minutes evaluate the state of the boiler through metered value from your control system. And this data evaluate automatically the status of the boiler, also including fuel calorific value, biomass calorific value, water content in the biomass. And we can provide feedback to the control system, maybe through operator, the optimum fuel supply, optimum air supply, primary, secondary supply, optimum, and this would be like a set points to the SCADA system where operator just put the data from one system and enter to the another system. In fact, finally, we can avoid human interaction here, and we can run this loop automatically full without intervention operator, and operator just do like monitoring of how the boiler is in operation. However, optimization process is run at full automated way. So, the digital twin philosophy is that we write mathematical equations fully describing thermal process inside the heat exchangers, pumps, flow, air flow, flue gas flow, including variable frequency drive. So it's fully described by mathematics. Also includes fuel burning mathematics. And all of these equations, mathematical equations, are solved each 5 minutes together and provide the required results. So real-time parameters and operation modes access through web. You can access all your operation data through web, and you can see here evaluated biomass, fuel consumed in each 5 minutes, water content, consumption, energy consumed in some indexes, kilogram of fuel per megawatt heat, or power, heat power, for example, this is a real case of a steam boiler. So you can control biomass calorific value. How you can control if you have possibilities to supply different fuel and make the fuel mix. So you can in fact control of a mix of the biomass. You monitor efficiency in real time, and the calculation is done in each 5 minutes, and evaluate biomass calorific value, moisture content, and also you understand impact to efficiency. And evaluate individual boiler components conditions. It's very interesting, but you can evaluate and we calculate individual components conditions in real time each 5 minutes. It's another example, it's a real example of more complicated boiler with produce steam, produce thermal oil, water economizer, another flue gas consumption in the technological process, filtering process, water heat, flue gas to water, and condensate economizer. It's flue gas pumps and an engine, so it's preheater of the air, and also biomass silo, biomass daily silo, transporters. You can monitor how much biofuel is delivered to daily silo, how much biofuel is delivered to silo, and how much biofuel was consumed each hour, each minute, in fact, each 5 minutes, and each hour. So set points. So yes, we provide optimum set points to your control system. You have access to unlimited historical data, PDF reporting, and for example, PDF reporting each hour. Each day, each week, month, yearly reporting, and biofuel mass accounting. Also. Reporting of in PDF, you can get emails according to your need. It's freely configurable. And so biomass boiler parameters and set points that should be optimized. So in fact, all set points which your operator make impact during the control of a burning process, we provide optimum set points value. It's amount of fuel, amount of air, furnace, grade, movement, flue gas, recirculation if a boiler inside exists this functionality. All these process parameters which operator make impact in hourly daily process, we provide optimum set points which should be delivered to the boiler control system. So efficient biomass boiler control possibility to reduce maintenance cost is quite interesting because during the control process, we make impact also as to the maintenance time between two maintenance. Flue gas temperature and temperature at the furnace are boiler operation status indicator, and amount of oxygen is related to amount of air supplied to the furnace. Also, part of oxygen is emitted with biomass fuel. So the idea is also to reduce oxygen amount in the flue gas, and this optimization, it's tricky. We understand this because if you have your mode of a boiler quite dynamic, I mean the dynamic change in heat demand and change dynamically during the day the calorific value of a fuel, the optimization is required, and you have always surplus oxygen because control system, as I mentioned in quite first slides, is not capable to control perfectly because have limited number of variables which could be controlled. For example, do not have a calorific value of a fuel. And surplus of supply air to furnace, increased temperature at a furnace, and amount of oxygen in flue gas and fuel surplus reduce boiler efficiency. So lifetime of a boiler is evaluated not by produced heat but by fuel combusted. So increase that efficiency for a long time period between maintenance. So if we increase efficiency, we in fact we prolong the time periods between the maintenance. We should come back also a little bit to theory about maintenance. It's bath tube curve, you remember from the university time. We have bath tube curve, so it's failure rate and it's initial failure rate when we build a boiler, and we have quite high initial failure rate. Even this initial failure rate could be after maintenance, so some part of even after maintenance could fail. And here would be our decision for the next maintenance. Here would be, in fact, a failure which really occur and we don't like to have this because we limit heat supply. However, the gap between this real fact failure and when we make decision of replacement of the equipment is the gap of safety. And if we have quite big gap of safety, so we lose, in fact, money. And this is value for customer, the value we can create. So in fact, we are proposing to move this curve a little bit to the right, go to the near to the aging failure curve, of course, not entering to the failure curve, and save money. Another example is, for example, we have two shifts. One shift is operating from 8 p.m. till the morning 8 p.m. Another shift is operating boiler also from 8 to 20 o'clock. And you can see here that first shift is operating boiler at 87% of efficiency. However, second shift is operating boiler at the 83 average, 83% of efficiency. I still allowing people to enter our webinar. So, and in some moment, the efficiency reduction up to 63% was recorded because of dynamic load, thermal load change. However, we can understand that one shift is operating boiler at average 4% less efficiency comparing with the first shift. However, the question would be, what is the maximum possible to reach efficiency without, for example, optimization? Yeah? And after power generation increase, here you can see another effect that it was a reduction of the heat demand, and this was increase of the heat demand. It's quite strange, but because during the reduction of the heat demand, usually a boiler operate at a better efficiency because it's less heat demand. However, this effect was absolutely opposite because the operator was not automation system, control system was not capable to reduce fuel supply effectively, and it was surplus fuel supply. And because this was surplus of fuel supply, we burned the fuel, and efficiency was quite bad. However, operator during its half-an-hour event, operator was not capable to make a real reaction to the process. And control system was not capable, in fact, to do this. But here, operator seems to be make a reaction, and when the thermal power demand increased, operator increased fuel supply. Seems to be automation system also increased because operator is just changing maybe set points, but the SCADA system, in fact, is supplying fuel. And you can see that the efficiency reached some steady state, stable value, not at the first half an hour, even it was near to 2 hours. Why? Because the surplus fuel was added to the furnace, and this fuel was burned through a couple of hours. Surplus fuel was burned through a couple of hours because of inertia effects. So in fact, automation system was not capable react to the process. Of course, here oxygen level was increased also, so we can understand also this efficiency for oxygen amount. So this, if it's not stable, we put extra fuel, and if we put that extra fuel, we reduce that efficiency. So the question we are solving now is Another example, 10-day period is, and we can check total efficiency of a biomass boiler and control error. I mean control error, what does it mean control error? We provide optimum set point and we compare this optimum set point with, in fact, real set point that was delivered by automation system, by the control system. And this is error, and this is efficiency. 92 is here, it's maximum what is possible for this boiler. You can see that in fact boiler operates its maximum 92, it's new boiler 92%, but in fact boiler operates like here. And because error depend also on the air error, it's air control error, it's efficiency also, it's another graph. But in fact, boiler operates here. If we don't use boiler optimum optimization, I mean error, it's fully optimum operation, it's zero error. Yeah. If the error streams to zero, the efficiency streams to 87%. It's 87%. It's maximum for this. In this example, is maximum what could be reached because the at this moment, particular moment, boiler cannot reach better because of a status of a boiler. And also air control error, that we see that if we control error bad, it's quite far away from the optimum set points. We operate in some limited efficiency instead of somewhere here optimum efficiency. It's maximum efficiency at optimum control. So you can understand that operator can operate boiler at 85–87% efficiency instead of, without operation, instead of 75–80% efficiency. And here is our decision. If we see without optimum control that the boiler in average daily, weekly average, according to fuel amount calculations, you can see here that our decision would be that the boiler efficiency is in fact 70, maybe 7, maybe 80%. So our decision error would be from 87 to 77. It's a 10% error decision. So we can in fact prolong our boiler operation and do not make mistake in the decisions. And if we operate boiler here, yeah, we do not operate boiler here, we can extend our boiler operation till the next maintenance activities. And also, it's just a money for the savings. And to understand what does it mean 75 to 85 or it's 10% of efficiency variation, this means 1 month fuel saving. 1 month fuel savings. And where's the problem with a control system? I mean, SCADA or boiler control system. The problem is that in fact we don't understand what is the calorific value of a biomass during the burning process. Control system is not capable to understand what is the calorific value, and we should somehow evaluate this. If we would have calorific value of a fuel, we can very, very perfectly control oxygen amount in the flue gas and like in natural gas burning process, or fluidized fuel burning process where calorific value is very, very well known. So we don't understand moisture content in biomass. And for example, here during the period from 11 to 12, the biomass fuel was rating in 40-45. However, it's increased to 50, 55, 53% water content. And accordingly, calorific value changed. Adding demand, thermal demand change, we would face that control system should be set at like in some average control to match different control range. I see a question from Ilmars. What is optimal upper and lower water temperature in the boiler? Upper, lower water. Okay. Maybe you asking me a question about a dew point of the flue gas inside the boiler. So supply temperature, in fact, we cannot optimize somehow a supply temperature of the water to the boiler. We should keep temperature, in fact, in some range which is defined according to dew point. It's a very interesting question, and this temperature, maybe your question is, can we reduce supply temperature of the water, or we should increase supply water temperature? But in fact, this should be according to dew point of the flue gas, and this would be according to the water content in fuel. So the optimization would be related to this. However, I would recommend you to keep according to manufacturer requirements. In fact, we don't optimize this point. We do not make impact on this. And if individually to your operation mode, this is very important, we can discuss with you during your project, because we usually discuss everything, all questions we discuss with you when we implement a project. But in general, usually we don't optimize because there is no need. We just keep the temperature quite high, as recommended boiler manufacturer. So human error that can be avoided using analytical system. In fact, we tell that operator gets assistance through EA-SAS Boiler IT solution, because in fact operator is operating a boiler without a tool which could recommend something. Automation system in fact operate in parallel, control the boiler burning process. However, operator should make decision to change one set point or another set point according to some individual operator experience. And this individual operator experience could be really different between two operators on two shifts. And this experience creates for you as a business owners, creates in fact losses, but these losses cannot be solved by operator themselves, because operator do not have tool, operator have only experience. So we provide assistance to the operator. And EA-SAS Boiler, it's an analytical system that monitors, so it could be called also as monitoring system, analyze and estimate boiler efficiency, control it in efficient way. And efficiency control, this mean that no efficiency of a boiler every minute. I mean, we allow you to get a knowledge about efficiency not after 1 month or 1 week or after 1 day, because 1 day it's a history, 1 week it's also history, but we allow you to understand in minute range, in 5-minute range, and this is now, because we are living now, so decisions could be made now according to the analytical system proposals and optimum set points. And you can always keep boiler efficiency at a maximum. You have data storage, so you can access to data at least for the 6 months. We can agree for 1 or 2 years, but at least for the 6 months you can get data about the operation of a boiler. Forecast, you can analyze historical data and forecast how to control boiler behavior in optimum way also. You can make your own decisions over our decisions that we are supplying. You can do predictive maintenance. You analyze data and predict and emerging maintenance issues before they become costly problems, because we see deterioration of the parameters through a time in 5-minute range. So what problems can be solved with a solution EA-SAS boiler? It's you can produce just more heat with less fuel, change boiler operation mode without losses, avoiding losses, optimize maintenance costs and decisions, and avoid human errors. A question from Andrus was, you talked about the water content in biomass. In order for your system to work, would it be required to add device and constantly measure moisture in the biomass? No. The idea of this solution that we are capable during the modeling simulation process, mathematical modeling process in real time in 5 minutes range, we are capable to evaluate calorific value of the biomass and water content. So you don't need to add extra devices which could measure moisture content in biomass. If you have possibility to weight the biomass, we can also include weight measurements in our EA-SAS boiler system as additional component, and it would be good, very good comparison from your biomass measurement device and our calculated value. However, you absolutely don't need to measure either calorific value, either water content, either mass which is delivered to the furnace. So this is done automatically by our algorithms, and these algorithms are tested, and when we would deliver project to you, we would do test also, because, for example, how the tests are done, you burn amount of fuel that you understand calorific value, and we compare data with data in the EA-SAS boiler system, and it would be like a commissioning, like a testing process, like a validation process that the algorithm is working perfectly. So coming back to the slides, so monitor, analyze, and estimate biomass boiler and increase efficiency, and performs real-time analysis every 5 minutes. So EA-SAS boiler solution would be beneficial for you if your operation quality depends on a person. I believe yes. If you have biomass boiler, your burning efficiency highly depend on operational persons. You are not sure that your what is efficiency real of your boiler. Your efficiency is unstable. I mean, you can calculate, as we saw from the slides earlier, that the efficiency even changed due to shift. And you would like to decrease maintenance cost, you would like to increase efficiency, you would like to stabilize efficiency, and would like to avoid human errors, I mean human impact on the process. And as we discussed it earlier, in fact, human or person who operate boiler do not have really tool which could really assist in the control of the boiler. Edgars from Riga is asking, what is precision or mistake of mathematic method calculated to real laboratory? Good question. Your boiler is real laboratory. And because your boiler is real laboratory, in fact, we are joking that why do you need laboratory if the boiler is real laboratory? We just should be capable to calculate in general. So yes, always when we are in laboratories, laboratory works, but when we are in real life, it's real life. And real life also could create errors of, for example, temperature measure, active, I mean thermal power measurements, pump air supply pump, flue gas, also ventilators. So it's related to many errors, but we can minimize because we have multi-variable. I mean, we have thermal consumption, thermal demand measurement, we have condenser thermal production measurements, we have temperature of the supply water, temperature of the steam or producer thermal fluid temperature measurements, we have temperature measurements inside furnace, we have air supply temperature and air supply, we have a lot of parameters which exist, and when you solve everything, all mathematical equations at once, you minimize error-to-error impact. And so we believe that it's in the range of 1% we can reach. Mathematics, why? Because if we are thinking about the efficiency of, for example, from 87, we should increase efficiency to 93%. So our calculation cannot be higher than the requirements to increase efficiency. So in general, if this is solved, what we are selling, in fact, we are selling a service. We are not selling software where you get a software and you should do something. No, we are selling service where we keep the quality of a service, and we keep quality day by day of a service. And you don't need to think what is inside. We are, in fact, selling you black box. You don't see mathematics, you get only results on this. And get feedback from us about these results. And it's our business to work on mathematics and the quality of mathematics. And your business would be claim us that mathematics is good or bad, or set points you get is good or bad, to optimize your boiler efficiency your business would be to put these set points to the SCADA control system and put without errors. I mean, if you provided set point 10, you should provide these set points to the boiler 10 at the right time. If you would put this set points late, after half an hour or 1 hour, you would be delayed, and after 1 hour would be another set point, for example. So our business is to provide quality of a control, set points of optimization, of algorithms, of mathematics, of web access, data collection, and etc. Your business is operate the boiler, and we don't mix these responsibilities. So, and the problems we solve. You produce heat in the best way. We produce mathematics in quality, the best quality to deliver you best of efficiency of a boiler. How we understand the process and how we do data collection. First is we collect the data, we install the data collection software, and we collect the data from the SCADA system and visualize all your data on EA-SAS Boiler. In fact, here you can stop. You can not do nothing more. You can buy just a collection and monitoring system. Just we visualize you on the web. You access to the data of a boiler through the web. But how? It is just a monitoring system. We are an office. We are proposing you more. In the of the boiler and specification, it's a pump, it's a fan. We need technical characteristic on your equipment. Next, about the processes, we get the also information, and we put to the boiler EA-SAS boiler system, and this data is saved. Next, we create a digital model. It's quite standard. It's not really complicated for the different kinds of mathematics. Shortly to your specific need. For example, the question was about temperature supply. So if it would be questions, we always discuss this and close these questions. So we prepare control tasks for the control, primary, secondary air control for the optimization perspective, and prepare maintenance tasks according to automated equipment status evaluation. So it's digital twin. So we provide you mathematics as a black box. In fact, you don't see this mathematics inside, but you get data as a result. As I showed at your previous slides, you get as in the tables, in the graphs, in PDF reports. Of course, also identifying KPIs. For example, you are willing to get some. For example, KPI kilogram of fuel per megawatt of heat, or efficiency just, or megawatt fuel needed required for a megawatt heat, and etc. It's many different requirements we have. So we adopt according to you and provide, even though we provide KPIs for operators, how we operate, how we are far away optimum I mean operation. For example, we provided set point 10 but operator than set point, so the error would be 10%, and we provide the table average error of operator control of a boiler from the optimum during each hour separate. And step 4, and this would be done. Usually we ask 6 months agreement on this, usually, because just for the project management issues and at coronavirus issues also, we just all of us are slower in speed because of limitations. But however, in general, it's for the project manager, and we do this faster. However, ask agreement for the 6 months, and after that, when we finish digital modeling, digital twin modeling, so you have efficient boiler control. You get the set points. You get information about efficiency, and you get maintenance forecast. So connect, digital twin, and operate. And this operation is related to, we issue billing each month, and this would be software as a service. We provide you service, and you pay a bill. Separate process of building processes, data collection, inventory, and digital modeling. Dashboards, what you get information to the dashboard. Dashboard is easily configurable, and boiler efficiency, economizer, components efficiency, biomass consumption, costs, energy prime, energy ton, biomass, calorific value, moisture content, access rate, change in dimensions, many not mentioned here. Also indexes which are required to understand you when you're controlling your business, when you're monitoring your business. And get reports also in PDF, immediate notification, for example, are separate. You can get email or SMS message, immediate notification as a head of management about something happened in boiler. So get daily, monthly performance reports. We even can separate, for example, one shift is operating in one way, another shift is operating in another way. We can separate with shifts. We can summarize shift performance, shift performance during the previous day. Operation insights, configurable in the report PDF, easily customized reports according to your needs. In fact, we have some template, but this template could be fully adapted to your requirements. And reports are saved in database for 6 months. PDF data, PDF reports saved in 6 months. However, this would be could be extended according to your requirements. And who is a user of a system? And the user, in fact, operator is the direct user of a system, because the EA-SAS boiler is assistant to the operator, and the operator constantly tracks system indexes. And control boiler, according to recommended control task, adjust control parameters at the SCADA system. Control parameters. However, some parameters also could be adjusted according to our proposal to the control system inside. This is not operator. Well, operator cannot make impact on this. Related to design questions. And head of a boiler house, of course, because he connects to the system periodically and get reports and track historical energy indexes and exchange, analyze results and plans technical maintenance. And technical manager also gets daily, weekly, monthly, yearly reports, evaluates operator work, motivates most effectively working operators, for example. Motivation system also make decision regarding to technical maintenance. So the system, it's not just monitoring, but also decision making, where you can make your decisions according to real data, minute, 5 minutes, hourly, weekly, and monthly data. And unlock boiler, return on investment with precise operation. It's data-driven decisions First, your decisions is made on data you get, and reduce human errors, for example, 10 to 30%. Operate boiler in optimize that efficiency. I mean, optimize that efficiency, but if a boiler in fact is not new, is operated and a couple, 3, 4, 5 months after the maintenance, efficiency slightly decrease, but our intent is that efficiency decrease not to reduce the speed of decreasing of efficiency through optimizing hourly, minutely of operation of a boiler. Increase personal productivity in general if you don't waste time on reporting, so you can do another jobs and you can be more effective and productive. And maintenance, we simply reduce maintenance cost in time range. In fact, we reduce maintenance cost through better performance of a boiler in hourly range. So this was my presentation. 7 minutes left. I was in high speed, but you can now raise your questions. I would be happy to answer these questions.